Assalamualaikum and hi. Today we're going to learn chapter 2, which is limits and continuity. So let's see the outline. The first one, we're going to see the epsilon and delta definition of limit. And the second one will be the limit of a function. So this is going to be a combination of a new chapter and the previous chapter we have learned last week. And the third one is calculating limits using limit laws, and the last one will be continuity. So let's see the first one, which is the epsilon delta definition of limit. So we're going to see what does it mean by these two symbol over here. We say that limit fx when x approaching a equal to L if and only if, given a positive number epsilon, there exists a positive delta such that if modulus x minus a less than 0 and greater than 0 less than delta, then modulus fx minus L must be less than the epsilon. So what you can see over here is that you have a function. We have learned about function before, and then you have a number, a positive number or any number, which is, we call it as a over here. We're going to see what is going to happen when the x approaching the a, the number. Then you're going to have a value over here, which is L. This L is going to find the value later, but it's according to this. Okay, so let's see this graph over here. You have a curve y equal to fx, a function of fx. So we have a point over here, which is this point coordinate is a, L. The x-axis is a, the y-axis is L. So what happens is that when you have an L over here, the y-coordinate is L, and then you're going to, if you shift from this point to the left with delta unit, then you're going to have a minus delta. That one is when you shift to the left. And then when you shift it a few units of delta to the right, it's going to be a plus delta. Okay, it's going to be the same for the y-axis. When you have this coordinate of y-axis, which is L, then when you shift it downwards with epsilon unit, then it's going to be L minus epsilon. But when you shift it upwards with epsilon unit, then you're going to have a new coordinate, which is L plus epsilon. Okay, so I hope you can understand about the epsilon and delta definition of limit. It's more like a movement, okay, about a movement of the coordinates. So let's see an example over here. Show that limit 3x plus 4 when x approaching 2 equal to 10. This is how we read our limit of a function. Limit 3x plus 4 when x approaching 2 equal to 10. Okay, so kita kena buktikan yang ini. But how we going to prove or show this limits equal to 10 is we going to refer back the definition which used epsilon and delta previously. This one in the box. So let epsilon greater than 0 be given. Okay, epsilon is always greater than 0. We need to find a delta greater than 0 such that if modulus x minus 2 less than delta. Why is it modulus x minus 2. Where did I find this? Where did I get this one? Is actually from here. Limit x approaching 2. So when you rearrange this thing, bring this 2 to the left hand side, it become x minus 2. Okay, then after you get this, you get 3x plus 4 minus 10 less than epsilon. So how do I get this thing? Is actually from this. Okay, I just refer back to the definition over here. Okay, this one is actually from this. I just follow this definition. And this one is belong to this. Okay. So I have this x minus 2 is actually because of this. I just bring the 2 on the left hand side. That's why it's become x minus 2 less than delta, because I just follow this one less than delta, and it must be greater than 0. So for that one greater than 0, you don't need to write it down. Okay, then for this one, 3x plus 4 minus 10. 3x plus 4 is actually the function. This one, the fx. This is actually your fx. Okay, and this is actually your fx. And this is your L. The 10 here is your L. See? Fx minus L. So we just write it down. What is your fx? 3x plus 4. What is your L? Your L is 10. So that's why I get 3x plus 4 minus 10 less than epsilon. I just follow back the definition given. But the modulus 3x plus 4 minus 10, when I solve for this, I get this 3x minus 10. When you expand this, you need to open the bracket and solve it. Then you get 3x minus 6. And then from here, I just factorize the 3 over here. So I take out the 3, put it outside. So you have 3, and then the remaining will be x minus 2. Okay, saya faktorkan dia dan bawa keluar 3 tu dekat depan, then you have x minus 2 inside the modulus. Then it's still less than the epsilon. We still follow this one, okay? So what happened is that if x minus 2 less than epsilon over 3. Okay, this is actually continue, just continue from here. What happened is that the 3 on this side, I just bring it to the right hand side. So it become x minus 2 less than epsilon over 3. Okay, this is just continue from here. So we choose our delta equal to epsilon 3 because this is actually our delta. If we refer back to our this one, the first definition, x minus a, and then you have your delta. So actually your a, this is actually your a, right? The 2 is actually your a. Okay, this one is your a. So you just put it inside the definition. Then you can show it or you can prove it. So that is the answer. So you choose the delta equal to epsilon over 3. Okay, that's it about the first subtopic, which is the definition of delta and epsilon delta. So let's move on to the second subtopic, which is limit of a function. Okay, so this one is a combination from what you have learned on the previous chapter, which is function. Now we're going to combine it, the limit and function. So we are not interested in the value of function fx when x equal to a. A is actually any value. So we are interested in the behavior of fx as x comes closer and closer to a value of a. Okay. So apa maksud dia dekat sini? Kita tidak berminat dengan value bila mana kita substitute a ni ke dalam this function. But what we are going to find is that the behavior. Kita tengok bentuk dia, ciri-ciri dia bila fx ni as x comes closer and closer. Bila x tu semakin menghampiri value A. Apa jadi bila dia x tu semakin menghampiri value A? So this is actually limits of a function, and the notation is given by this. Okay, limit fx, limit of a function when x approaching A. A is any value, any numbers, equal to L. L will be the limit. Okay, so the limit you will have numbers for that. Okay, let's see the example. Determine limit x square plus 1 when x approaching 0. Okay, so dia kata you have this function x square plus 1, but now you have to find the limit when the x approaching 0. So when x approaching 0, you can have two cases. The first one is x approaching 0 from the left, where the x values start from the negative numbers or the negative values. Negative 1, negative 0.5, negative 0.3, negative 0.001 up until it closer to 0. Okay, that one is from the left. But you can also approach the 0 from the right. Okay, so from the right kita akan ambil any numbers from the positive value. So for example, you have 1, 0.5, 0.25 up until it reach 0. Okay. Okay, so that one is, what does it limit mean? So, okay, you have two cases when you have x approaching 0. It can be from the left and it can also be from the right. And at the end, you will get the same answer as it closer to, as it approaching 0. Okay. So how do I find this value? It's just that I simply substitute the x value into the function given. So the function, what is the function? This is your function, right? This is your function. So I just substitute the x value. Not necessarily 0. I just pick any number that is nearer to the 0. Pilihlah any number yang berdekatan atau semakin menghampiri 0. So that one is using table. Okay, when you substitute using table so that you can see the fx. Okay, then this fx is actually you akan dapat satu value lah until you get this 0. And then this is how the limits looks like when you use a graph. Okay, you have a function x squared plus 1. So of course this is a quadratic function. You're going to have a U shape like this. And then when it's approaching, let's see, when x approaching 0 from the right. Okay, x approaching 0 from the right. How do I know it is from the right? Because of this positive number. When you have x approaching 0, plus mean from the right, like this. Any number from the right. It can be 10, 5, 2, until 0. Okay, and then we have, then you can see the graph. You can see the behavior of the graph. It's moving towards the 0 over here. Okay, and then you have x approaching, when x approaching 0 from the left. Okay, so this is from the left. When you have negative, it means that you're approaching 0 from the left. So how does the behavior of the graph? What happened to the graph is that it's moved on downwards, approaching the 0. Okay, dia turun, semakin menurun. Okay, dan semakin menghampiri 0. So the limit x squared plus 1 for when x approaching 0 from the left is actually equal to the limit of x squared plus 1 when x approaching 0 from the right, which is the answer equal to 1. Okay, so this is actually 1. You see over here, this is 1. This is 0, right? Bila dia menghampiri, bila kita tengok graf ni, daripada sebelah kanan, bila dia turun, dia akan bertemu dekat satu point dekat sini. Okay, the y coordinate of the point is actually y equal to 1. It's same, go to for this one from the left. When you go through the graph, this is from the right, you see, and then it will meet in at here, at this point, 1. And it same goes to the right hand side. Bila kita tengok graf tu turun, dia akan bertemu di titik yang sama, which is y equal to 1. Okay, this one. That's why the answer equal to 1. Okay. That is limit. Okay, when does a limit exist? Bila limit tu wujud? Okay, so for example, you have fx equal to x squared. This is how the graph looks like. So different values of x have different values of y. Yes, when you have, for example, you have x equal to 1, the value equal to 1 over here. If you have x equal to 2, then the y value equal to somewhere on here like 3. Okay, and if you have x equal to 3, then the value is getting bigger for y. Okay, so we can say that different values of x have different value of y. Okay, as you go down or as you go through the curve. Okay, then for example over here we pick x when x approaching you have limit x squared, limit of function x squared when x approaching 2 from the left. This is from the left, and it's from the right, limit x approaching, limit when the limit x squared, x approaching 2 from the right. So you see that this one is from the right, and then you have sorry, this one is from the right, from here. Okay, and then from the left, dia akan bertemu dekat di sini, di 4. Okay, so this is from the right, which is 2 positive. This is from the left. Okay, at the end dia akan bertemu di tempat yang sama. So this is when does the limit exist. Satu, syarat dia kamu akan dapat satu jawapan yang sama bila mana limit tu daripada, no matter it's from the left or from the right, you will get the same answer. That means that your limit exists. And one thing is that the curve must be continuous. Dia mesti bersambung. Kalau you have a graph look like this means that the limit does not exist, because obviously the curve over here is disconnected. Okay, dia terputus. But this one, the curve is connected. Okay, so this is limit exists, and while this one, the limit does not exist. And why does limit does not exist? Because when you are given limit of fx when x approaching 4. So this is 4. Let's see limit from the right, limit from the left for 4. The answer is 1. But limit from the right, daripada kanan menghampiri 4, the answer is 2. So you have two different answer. 1 and 2. So obviously the answer is different, thus your limit does not exist. It should be like this. Limit from the right, limit from the left and the limit from the right should be the same. Then only you have the limit exists. Okay. Okay. Then we see what does it mean by right hand limit. Okay, right hand limit, actually we have touched this before. Right hand limits mean, for example, if you have limit of a function when x approaching 4 from the right, the positive one. Okay, from the right, right, this is 4 approaching 4 from the right, dari sebelah kanan. So, yang mana graph dari sebelah kanan? This one, right? You look at this graph. Dari sebelah kanan, then you get equal to 2. Okay. So, that is right hand limit. Kita panggil sebagai right hand limit. How about this one? Yeah. How about left hand limit? Left hand limits mean you have a negative over here, which means that when you are given a function x approaching 4 from the left, so it's approaching 4 from the left. So let's see which graph or which curve you're going to choose. Of course, this one, right? Because the curve is actually coming from the left. So the answer is equal to 1. Don't refer to this because this curve is coming from the right. Okay, so this is right hand limit, this is left hand limit. Anything that comes from the left is left hand limit, or you get this negative sign on top of the A. Okay, then we have this one. Limit of a function when x approaching a exists if and only if limit fx when x approaching a from the right must be equal to the limit of fx when x approaching a from the left. So we have discussed this before. The limit must be the same whether it's from the left and from the right. Okay, then only your limit exists. Okay, let's move on to one-sided limits over here. We have one-sided limit. Limit satu belah sahaja. Okay, so the definition, we write limit fx when x approaching a from the left equal to L, and say the left-hand limit of fx as x approaches a. So this is how we read it. Okay, is equal to L if we can make the values of fx arbitrary close to L by taking x to be sufficiently close to a and x less than a. Okay, similarly we write this one, but this one is x when the function of fx as x approaches a from the right. So this is actually right hand limit and this is left hand limit. So when we just going to check for example for this one, we call it as one-sided limit. Bila kita cuma check satu belah saja, for example from the left or for example from the right, only from the right, then we call it as one-sided limit. Okay. Then important, what is important over here, you can see that limit fx equal to L for Sx approaching to A if and only if this one, actually this is what we have touched this one before. It's actually more about the existence of the limit, whether the limit exists or not. So you can write it down in this way. This one and this one must be the same. And this one actually dia kata limit x approaching A. So ni wujud, this one wujud if and only if sebelah kiri and juga sebelah kanan dia sama. Okay, the value is the same. Okay, let's see more example. The graph of function g is shown below. Use it to state the values if they exist. Okay, use it to state the values if they exist. Okay, so let's see. A, limit of gx as x approaching 2 from the left. Okay, this is curve gx. Okay, you have these two disconnected of gx. Dia terputus graph gx ni. So dia kata when x approaching 2 from the left. So x approaching 2 from the left, which one you should choose? This one or this one? Okay, kita tengok graph mana yang datang dari sebelah kiri. So obviously it is this one. So you're going to choose this one, this graph over here, because it's 2 from the left. Okay, so what is the answer? Bila dia approaching 2, this is 2, right? From the left. So the answer equal to 3. Okay, so you will get the answer equal to 3. Okay. And how about this one? Limit gx when x approaching 2 from the right. Okay, so similar. This is 2, but you're going to see it from the right. Tengok mana curve yang datang dari sebelah kanan. So this one. Datang dari sebelah kanan and they stop dekat 1. So the answer equal to 1. And this one, limit gx when x approaching 2. Okay. So they just kata x approaching 2. There is no sign above over here. Not negative. Either negative or positive. Neither negative or no positive. Okay. Dia tidak dua-dua. Sorry. Maksudnya, ini mewakili these two. Okay, remember this one. Bila dia just letak 2, maksudnya you gonna check both from the left and from the right. Okay, so you have checked it previously. You have this x approaching 2 from the left and x approaching 2 from the right. Okay, you have the answer 3. One of the answer is 3 and the other answer is 1. So obviously for this one, the graph does not exist. D and E means does not exist. Okay, I just write it down as in short form. Why does it not exist is because you have 2 different answers for this one. It should be the same because we have learned that before, right? The condition for the graph to be existed is the limit from the left and limit from the right must be the same. Okay, then let's see limit gx when x approaching 5 from the left. Okay, where is 5? Here is 5. So let's see 5 approaching from the left of the 5. So it's actually here, somewhere around here, right? So the answer must be 2. This one is 2. The answer is 2. Tengoklah mana kita terrefer kepada graph atau curve tu. Dia dari sebelah kiri, tengok sebelah kiri menghampiri 5. So when it comes closer to 5, then the answer is equal to 2. So you get 2 over here. And let's check when it's come closer to 5 from the right, dari sebelah kanan pula. So kalau dari sebelah kanan, you tengok sebelah sini, sebelah kanan, the curve dari sebelah kanan, then it reached the same point, which is 2. Okay, which means that this from the left and from the right is the same. Then the limit x approaching 5 equal to 2, and the limit is actually exists. Sebab jawapan dia sama and the graph is connected dari sebelah sini and sebelah sini. Dia guna curve yang sama. Okay, so this one limit exists and it's equal to 2. Okay, now let's see how do we calculate limits using limits laws. Okay, there are a few of laws for limits, so you have to carefully choose or understand each of these. So suppose that c is a constant and the limits fx x approaching a and limit gx x approaching a. So you have two functions f and g. Okay, the two limit exist. Then dua-dua dia beritahu dua-dua limit ni exist. Then if we happen to add these two limit, for example limit fx plus gx plus, you see plus gx when the x approaching a. So for this one, you can actually write it down in this form. You can break it into 2. Okay, as long as the x approaching a. Okay, I mean that this one, the a is the same, you can break it. Boleh pecahkan dia, but kalau dia tidak sama, then tidak boleh lah. Okay, then second one, if you have limit fx minus gx, when x also approaching a, then also you can break it down. You're just only the sign or the this one is different. Okay, the operation is different. And then when you have limit c fx when x approaching a, c is a constant. So if you have a constant, you can bring it at the front. So you have this one. And when you have a multiplication of limits, it's quite similar with the modulus and with the additional and subtraction. You can just multiply these two limits. Okay, and you have when you have a function, when you have division, hasil bahagi, then you can write it down as well like this. Okay, dengan syarat semua ni your a over here is the same for both function. Okay, and for this division, remember the gx must be not equal to 0. Okay, kita tidak boleh, yang bawah ni tidak boleh sama dengan 0, otherwise you won't get any answer. Okay, it is invalid. And then number 6, when you have a limit and then to the power of n, this is actually equal to the power of the whole limits. Okay, when n is a positive integer. And when you have limit c, when x approaching a and c is actually a constant, you will get the constant back. For example, limit 3 when x approaching 0. So you will get the answer as 3 again, because that one is just a constant, so you get the answer back as a constant. And then you have number 8, when you have limit x, then it's equal to a. Okay, and when you have limit x to the power of n, and you can also write it down as this one, a to the power of n. And when limit x square root, okay, kita ada punca kuasa dekat sini, then you will get this. And the last one, when you have square root or punca kuasa any number, then you can write it down as well like this. Okay, so that are all 11 laws of limits. Okay, let's see the examples. Number 1, limit for x squared minus 3x plus 5 when x approaching 3. So what happened is that this imply the first and second law. What is the first and second law? Over here, I just wrote it down. First and second. First is addition. Second one is subtraction. If you refer back, they follow this law. Yang number 1 dan number 2. Okay, dia ada tambah, dia ada tolak. That's why I just put it on 1 and 2. Then you have limit 4x squared. You can simply break it into 3 limits like this. Limit 4x squared minus limit 3x plus limit 5. Okay, then you can solve this one. Okay, since you have 4 over here, okay, you have 4. 4 is actually a constant. You can just put it outside. That's why I have this 4 limit x square minus, and then this 3 again is a constant. I just put it outside, 3 limit x, and then I just write it down again, limit 5 over here. So this is actually the limits, the laws that I use. Okay, 3, 1, 2, 3, 7, 8, and 9. So you can refer back what is this law means from the previous slide. Okay, from here, limits x squared. Okay, for this 4, I just write it down as 4 x squared, meaning that I have to substitute the x equal to 3 into this. Then I get 3 square. And for this 3 times x is actually 3. So I just write it down as 3. And how about when you have a constant? Remember, when you have limit of constant, this is actually lowest number 8. Okay, when you have, lowest number 7. Bila you ada constant, you akan dapat constant tu balik. That's why I get 5 over here. Okay. Okay, that's how you solve your limits operation, operasi limit. Okay. So don't worry if you have x values over here, you just substitute the x with the value of a over here. Okay, this is a, your a. Sama lebih kurang macam function. You just substitute it. You just substitute the value so that you can find, you get the value over here. Then you can solve it. Okay, it's similar to the second example, but this one is involve subtraction, plus, and also division. Okay, dia tambah, tolak, dan juga bahagi. So from here, you can write it down like this. Okay, boleh pecahkan dia. So now after you dah pecahkan, it's more easier for you to break it down into smaller limit. Okay. So, bila you dah pecahkan dua ni, satu dekat atas, satu dekat bawah, then you can pecah pula yang this one. Limit x square, then you minus limit x plus limit 1. Same goes to the denominator dekat bawah ni. You pecahkan juga. So, it become limit 2 minus limit x. Then you can solve for each of these. Okay, again, let's continue with this. Limit x square. Okay, you just substitute it. What is your x value? Your x value equal to negative 1. Negative 1, and then you square it, then you get this one. And for this one, x, just x, then you just write it down as negative 1. And again, this one is 1 as a constant, and then limit for a constant, you will get that constant back. Okay, and you can solve for this, of course. At the end, you will get the answer, which is equal to 1. Okay, so that is how you apply the laws, the 11 laws into the operation of limits, how you solve your limits. Okay.